Hello, my name is Aaron, and I did my project on security and bed management systems. So what I'm going to be talking about during this presentation is what a bed management system is and why it is important. Then I'm going to be talking about three different methods of hacking that are common in bed management systems. So I'm going to be talking about malware injections, port scanning, and ARP poisoning. And I'm going to be talking about what exactly they are, some different kinds of uh, hacking under these topics. So like port scanning with SYNAC hacking. And also, I'm going to be talking about preventative measures to prevent any of these from happening in the first place. So now I'm going to talk about what a bed management system is, the significance of the bed management system, and why a bed management system is a high value target. So first, what is a bed management system? A bed management system is a program incorporated to make medical workers have easier access to visualization of bed occupancy. It marks what beds are available and what beds are not available. This is important as it allows for medical workers to bring in new patients as soon as a bed becomes available. It also allows for viewing how many patients total there are in the hospital system and also gathering information about different patients. So, what is so important about a bed management system? For hospitals, this system allows for medical workers to take a new patient as soon as possible. This is important because in a hospital setting, everything is about timing. The reason it's important is that it also helps maximize the usage of beds. If there wasn't a system in place to show which beds were occupied and which weren't, then it would be hard for medical workers to know how many beds are open for new patients. For the same reasons mentioned above, it also reduces wait times because having a system that shows when a bed opens up lets medical workers take new patients as soon as possible. Another major thing about this whole system is that it also stores information about patients, so things like medical records. So there are several reasons why a bed management system is a high value target. For one, a bed management system stores sensitive patient information. So this could be things like full name and date of birth, medical record number, diagnosis and treatment information, room and bed assignment, insurance details, emergency contact information, and medical allergies. So, another reason that it is a high value target is that it can disrupt hospital functions. So, bed management systems store how many beds are occupied and how many are unoccupied. And so, if there are a few beds that are actually taken up, it can the hacker can make the whole bed management system where it shows all beds as being occupied, and so it tricks the medical workers into thinking that there's no space to take new patients in. This would hinder the care for people that actually need help, and it could also disrupt things like money access to hospitals. And on a similar topic to point number one, ransomware from sensitive data. So, if the hacker obtains a lot of data that is stored about the patients, they can delete data from the database itself in the hospital and keep that information for themselves and force the hospital to pay to get that data back because losing a lot of data like this would harm the hospital significantly. And the final point is that once the hacker gets access to the hospital system, it will allow for access to a whole network of hospitals. And so it would be able to collect information from many different hospital systems and also prevent communication between those two so that hospitals will not be able to get as much information. So for the first hacking method, I'm going to be talking about malware injection. So I'm going to be talking about what it is, how it relates to bed management systems, how it is done. I'm not going to be explaining too many details about all the different malware injections. I'm just going to be talking about one specific thing called XSS. And then I'm going to be talking about potential damages to the BMS system and also explain possible mitigations to this. So, what is a malware injection? A malware injection is when an attacker inserts malicious code into a system, application, or network. This code is designed to perform harmful actions like stealing data, corrupt files, or giving the attacker unauthorized access. It often happens through vulnerable software, insecure websites, or phishing attacks. Once the malware is injected, it can silently run in the background, causing damage or spreading to other parts of the network. So how does this relate to a bed management system? Malware injections can be something like ransomware, which, as mentioned before, will capture data in the database and hold hostage the information and make the hospital pay for that information back. It can also cause reputation damage from that attack because it shows the bed management system is weak. It also can be used to manipulate bed assignments of high target profiles. Say, for an extreme example, that there's a person that's known to spread misinformation online and also spreads hate crimes. If this person is admitted to a hospital and is in a bed, that bed management system will note that the bed is occupied by that person. But if a hacker goes in and marks that bed as unoccupied, it makes medical workers not care about that room and just not take care of them. So this could lead to the person's death by not being taken care of properly, or also allows for people to go into that room and do anything they would like. So how is malware injection done? There are a few different ways to do it. For example, phishing emails, we've all seen those in like Gmail that we get for things like study or researches. Those research studies are not real, as they say that they're going to pay like $30 to $40 an hour for the person's time, but where would that money be coming from? It's not real. The next one is web-based BMS interface vulnerabilities, and so that's what I'm going to be talking about in more detail. And then there's infected USB drives, so USBs can store anything, and if you just plug it into a computer, then it could just activate code. Social engineering and SQL injections are other ways to do it. So cross-site scripting attack is also known as XSS, and that's what I'm going to be talking about in more detail. So it is a script that is disguised in a web page link, and it could do things like stealing cookies, altering appearance of pages, expose data, and also creates vulnerability. So how is this cross-site scripting attack done? So it is mainly done when there's an HTML request. So if there's a submit button in a form of an HTML document, that opens up a possibility for the hacker to run scripts. So take, for example, this link. This is a normal link. So the regular thing would be example.com, and if the person puts into a text box placeholder and clicks submit button, it would show $Q equals placeholder because it just shows what they submitted. Now, if the person does something like putting in a script that does alert or something like that, for example, then it would actually run the script because HTML will just run anything if it's not actually taken care of. I could not get this one to work specifically because a lot of search engines already take care of this and prevent this from happening in the first place. So this specific link would actually work. And just to show you, I created a program. So here's the program, and if I run it, it'll pop up this page, and so the basic idea is that here's a search box, and so if I type hello and just click search, it would show up here that after the question mark, it would show hello. Now, if I typed in that code I showed earlier, it would be something different and actually run the script, and it would actually alert that there's XSS. Now, you may be wondering who would fall for this because it obviously looks like something suspicious, and that there's different ways that you can hide it. For example, if you have this sample code, this sample code does exactly the same thing as what was shown before, which is this sample code. And there's just different unique things about JavaScript that you can do to hide what the code actually does. And also, you can hide things like script with different encryption methods like this. A way to bypass the system in different ways for search engine filtering, you can also do things like this where it will append two different strings, and if the website is not that secure, it would actually add this together and do the same thing by running this script. Now, one way to prevent this kind of attack is to simply just take any input and convert it to a string so that it doesn't run that code. Another way is to do something like filtering different words like script or bracket scripts, one on error, JavaScript, or eval, just different keywords that you can pick up to basically know that it will run a script. Now, as mentioned before, with malware injections, there's a lot of different potential damages, but a few of them are disrupting bed updates, disabling bed management system integrations, patient record manipulation, and also create inaccurate bed assignments. Now on to port scanning. So I'm going to also be talking about the same topic. So what is it, how it relates to BMS, how it is done, also potential damages to the bed management system, and also possible mitigations. So these are 6 port scanning techniques. So ping scans, vanilla scans, SYN scan, Xmas, and fin scan, FTP balance scan, and sweep scan. The one that I'm going to be describing is SYN scan just because it's one of the easier ones to do. So what is a port scan? It is essentially a computer constantly iterating through different common ports in a system and seeing which ones are open. It also reveals security weaknesses like firewalls, and also it basically can create a backdoor to hackers, allowing them to enter anytime they want. They can also view traffic, such as packet information, and also gain access to different information like communication between medical workers. So like I've mentioned before, with how it relates to bed management systems is that it finds entry points in critical infrastructures and also creates backdoors for ongoing data access so that it allows for hackers to be able to enter whenever they want to. It also enables them to do things like denial of service attacks and also exposes bed management authentication, leading to bypassing security. It also leads to accessing interconnected hospital systems. So how is port scanning done? Computers communicate with different processes by ports. The lower numbers, such as port 80 being common for HTTP, is important to know. Computers need to know which ports are open and which are closed. There are different protocols that handle communication, such as UDP and TCP, TCP being more secure protocol, as it has many more rules to it. An important thing to know about TCP is that it opens a connection only through 3-way handshakes. This handshake is initiated by the client wanting to open a connection with the target computer by sending a SYN flag to the computer. That target computer, if available, will respond with an ACK flag, short for acknowledge. This ACK flag means that port is open. At this point in the TCP handshake is the focus of the SYN attack. One such example of port scanning is the SYN scanning attack. With the SYN attack, the attacker can easily find out which ports are available by just sending SYN statements to all ports on that target computer. once a port has been found that is open, the server will send a SYN-ACK statement. In the three-way handshake, it is first the client sending to the server a request to connect, the server responding to that request, and the client responding to that response. However, in the case where the server sends the responsive acknowledgement for the SYN flag, instead of responding properly, the attacker can respond with an RST flag, which means reset. When the server receives the RST packet, the server immediately closes the handshake, but the reset does not tell the server to close the port, but rather keeps listening, which then notifies the attacker that that port is open and also keeps it open for initiation of a doorway to that system. Now, I could only find a way to do this in Linux, but I couldn't get this to run properly, but you would install Nmap, which is a software that handles the port scanning for you, and you would type something like this. So a few other methods are something like vanilla scan, which is one of the easier things to do with port scanning. And this doesn't try to hide anything that it does. It basically just tries to send a SYN flag to all ports and simply just receives a message whether that port is available or not. It doesn't do anything else. And as mentioned before, the SYN scan will send a SYN flag and wait for a response of SYN-ACK by the server, and the scanner does not respond back with a SYN flag. It just responds back with a reset, and it learns whether the port is open or not and opens access to entering the system easier. Another way is a sweep scan, which basically the attacker will send to many different computers a SYN statement to a specific port, and that's the target port for all of those different computers just to see which ones will respond. This identifies whether the system is in use or not. So mentioned previously, there's a few different potential damages to the bed management system with this type of attack. It opens up opportunities for other methods of hacking, such as denial of service, which basically, if a port is a doorway to a computer, it will allow many different computers to connect that same port, given that it's the hacker attacking. And it also allows for unauthorized access, of course, mentioned with the doorway to the network. It also allows for malware deployment because once the attacker has access to the system, they can do whatever they want in that system. It also causes things like financial loss because data breach, because the person can delete a lot of information that would originally make the hospital profit, or the person can take a lot of data and basically lock it away, making the hospital pay for that data back. Now, for mitigation techniques for port scanning, there are a lot of different port scanning tools out there. One such tool that we are probably all familiar with was from networking class, which is Wireshark, which basically allows people to view the network and also see what malicious things might be going on. Programs can also be put in place to monitor ports at all times and alert when new connections are made. There are also IP scanning tools. Creating a strong firewall is also important, as it will prevent these things from happening in the first place. And there's also TCP wrappers, which are essentially a set of rules that when a connection request comes in, the process of running through the rules is done, and basically it locks unauthorized IPs, it logs all connection attempts, and also delays responses, which basically hinders the process of scanning ports, making it slower and less useful. So now on to ARP poisoning. So what exactly is ARP poisoning? So first, ARP is short for Address Resolution Protocol. What an address resolution protocol does is connects an IP, which is Internet Protocol, to a MAC address. A MAC address is the media access control in a local area network. One difference between the two is that they are different in bit size, IP being 32 bits and MAC being 48 bits. ARP translates between the two both ways. So why is it important? Media access control, while being a somewhat descriptive name, is not completely understandable. MAC represents the data link layer of the computer layer network. The importance is that this establishes and terminates a connection between two physically connected devices so that data transfer can take place. When a computer joins the local area network, as mentioned above, an IP address is assigned to the MAC address of the computer. The MAC address is unique to that physical computer. ARP is the program that when something is sent to the specific IP, it will search for the MAC address that is associated with it. The MAC receives the message. The ARP stores a sort of table that shows which IP addresses are associated with each MAC address within the local area network. This allows for searching to see if it is a valid location to send to. So now on to how it relates to bed management systems. So first, it can intercept login attempts, which gains unauthorized access to systems because when you redirect traffic, you can get information that the medical worker types in. So when they type in their login information, you have that information. And so now you can act as that person. And it also redirects bed management traffic like mentioned before. And so they'll get any information that is inserted into the database, which also man-in-the-middle attacks to alter patient records or bed assignments. And also, it can disrupt communication between medical staff and the bed management system, which is basically man-in-the-middle attacks. So how is ARP poisoning done? As a simple understanding, ARP poisoning consists of the attacker sending an ARP reply message to the network gateway in the local area network. This message would consist of false information. The attacker will say that the target's IP address is associated with their own MAC address. This will allow for viewing of messages such as a man-in-the-middle attacks. It can also lead to denial of service attacks. This man-in-the-middle attack would lead to many different problems in a bed management system, as there are a lot of different pieces of data that are meant to be hidden and not revealed to public. There are different utilities for performing ARP poisoning. Although there are not many resources explaining how it is done programming-wise, one popular one is a Python library called Scapy. This allows for creating ARP packets and also monitoring packets. Scapy can be used both ways, poisoning and preventing the poisoning. So this is just a random image I found online. Of course, I'm not going to be showing my stuff because I don't want y'all to know my IP address or physical address, but either way, this is an IP address, and this is the physical address of the computer. And the type is basically, when it says static, it will not be able to change, of course. And when it's dynamic, it basically means that you can change the IP address or the physical address to be associated with something else. So what are some potential damages? As mentioned before, with credential theft, the hacker can steal information because when they do a man-in-the-middle attack, they will gain access to whatever the medical worker puts in. So when they try to log in, it will give that information to the hacker. It can also intercept patient data, so it can take in any data that's inserted into the database. It can also redirect traffic and also session hijacking and also denial of service. So what are some possible mitigation techniques for this type of hack? So you can determine which type of ARP attack it is, and that will allow for knowing which way to take. And some other ways to mitigate it are using VPNs and also static ARP between commonly communicated devices like mentioned before in that example. So you don't want to change things that are important. So make it impossible to change an IP address that is associated with a MAC address. And there's also packet filtering. And that's all for my presentation.